Question 10. Part A then first. Two functions such that the derivatives are equal, but they need to be different functions, don't they? H dashed x is equal to 1. K dashed x is equal to 1. So H dashed x equals K dashed x. But Hx does not equal as a function k of x. And that's the counterexample we wanted from the question. Counterexample. Okay, part B. Here's our f and g with domains listed. F minus 1, first of all then. Okay. So y is equal to 2 ln 4x plus 5 plus 3. Y minus 3. And then move the 3 over there, move the 2 underneath after. Is equal to ln. Ln is log e. So I'm going to write log e now to make it clear. It's the same thing. But this is easier to see what we're going to do now. E swings down and hits this in the air. So the 4x plus 5 that will be left when we unwrap the log, the e swings down and hits this stuff in the air. Y minus 3 over 2. And then we get 4x is equal to this. Y minus 3 over 2 minus 5. And then I'm going to move the 4 down to divide on the other side. So I'm going to put it like that. Or I'll put it all over 5, I think. All over 4. So I'm going to get rid of this 4, move it down at the same time, save me writing a fresh line. So the inverse then, swap the symbols, and we get f minus 1 of x is equal to, the x becomes the y becomes the x, e to the x minus 3 over 2 minus 5 all over 4. And that's the inverse function. Now what does it say for as far as the question is concerned? Find an expression for that, which we've done. Write down the domain of f minus 1. So what is the range of f? Okay, the range of f then. So 760, we got 2 log 4x plus 5. So if we think about that, it's going to be a log function. 5 minus 5 over 4 minus 5 over 4. No, that's the asymptote then. And it will be okay, so 7 and 60. So the log function, just when x is 3 over 4, no, minus 1. When x is minus 1, it goes through 0. So here's the curve I was just trying to get a look at, like so. But basically we're going from 7 up to 60. And there's the points that I'm interested in. And the curve just carries on going up, doesn't it? Like so. So it will be, because this is closed and this is closed, these are closed points on the y-axis. And that would be the domain of f minus 1, because that's the range. So domain of f minus 1 will be, put 7 in. So this value will be 2 ln 28 plus 5 is 33 plus 3. And this value is 2 ln 245. So the domain 2 ln 33, hang on, plus 3 at the end. 2 ln 33 and 2 ln 245. Oh, to 2 ln. There we go, nearest integer. So when they say the nearest integer, this is the question I'm gonna, giving the endpoints of your domain correct to the nearest integer endpoints. So let's have a look. 2 times natural logarithm of 33 plus 3. 9.99 is 10 and 245. $14. That looked pretty user-friendly there. So that was part 2. Now what's g of f of x? Part 3, let's go back to the paper and simplify your answers. So just g of f of x then, e to the x. So g of f of x is equal to g of f of x, which is equal to g of 2 log 4x plus 5 plus 3. And then g is e to the x, isn't it? E to the x. So it's e to this. Which is equal to e to the ln. So I'm going to split it up. E3 is plus, so I've just put that there. Then the 2 I'm going to put here. 4x plus 5 squared. E log are now next to each other, so they one is the inverse of the other. So it's 4x plus 5 squared times by e cubed is the composite function.